Welcome to day 14, Pythagorean Identities. What we're going to talk about today. Recall that the sine and cosine we've now defined in terms of the unit circle. The radius of this circle is 1, it's centered at the origin. And for any point on the circle, the angle of rotation, starting at 0 to get there, angle theta, is an x and a y coordinate that are cosine theta and sine theta respectively. And the radius of that circle is 1. So if we draw a triangle, and it doesn't matter where on the circle we can draw this right triangle. And the horizontal leg of that triangle is going to be, the length of it is going to be equal to the opposite theta, cosine theta. Or, anyway, this is going to be cosine theta. That's how far you move from the origin to get to that point in a horizontal direction. And the y value is going to be equal to sine theta, the vertical leg. Because this is a right triangle, we can apply the Pythagorean theorem and say that cosine squared theta, square this leg plus square this leg equals the square of the hypotenuse, plus sine squared theta equals 1. And this is the first Pythagorean identity. I'm going to go ahead and derive the other two. There's 3 of these. Okay. If I take the first Pythagorean identity, I divide both sides by cosine squared theta. So I divide everything by cosine squared theta. Cosine squared theta divided by cosine squared theta is 1. And sine squared theta divided by cosine squared theta is the same as sine theta over cosine theta times sine theta over cosine theta. Both of those are tangent theta, so that's tangent squared theta. And 1 over cosine squared theta is the same as 1 over cosine theta times 1 over cosine theta. And those are each secant theta. So this identity becomes 1 plus tangent squared theta equals secant squared theta. And that's the second Pythagorean identity. To derive the third, we'll go back to the original, the first identity, cosine squared theta plus sine squared theta equals 1. This time we'll divide both sides by sine squared theta. And using the same reasoning as we had here, we get cosine theta over sine theta times cosine theta over sine theta. That's cotangent squared theta. Sine squared theta over sine squared theta is just 1. And as we did over here, this is 1 over sine theta times 1 over sine theta, or cosecant squared theta. And this is the third Pythagorean identity. And because of this, if we know where on the circle an angle lives, so if I gave you a diagram that showed this and said we've got an angle theta, it doesn't matter if it's a negative angle theta or if it's a positive angle theta, or if it's positive larger than 2 pi or negative smaller than negative 2 pi, as long as it ends here, let's call this the angle theta. Then I know that the cosine of theta is greater than 1 because it's on the right side, or greater than 0 because it's on the right side. The sine of theta is less than 0 in this part of the circle. The tangent of theta, because the sine is less than 0 and the cosine is greater than 0, negative divided by positive means the tangent is going to be less than 0. The cotangent then is going to be less than 0 because it's just the reciprocal of the tangent. The cosecant is going to be less than 0 because it's a reciprocal of sine. And the secant is going to be greater than 0 because it's the secant of the reciprocal of the cosine. So if I gave you this diagram and I told you that cosine theta is equal to, let's say, 2/5, and find sine theta, secant theta, cosecant theta, tangent theta, and cotangent theta. We're going to use these Pythagorean identities to find that. The first thing I have to identify is if I'm going to find a sine theta, because I can use this first Pythagorean identity, say cosine squared theta plus sine squared theta equals 1. I need to identify whether the sine, when I go to find it using this identity, is going to be negative or positive. And we've already established the sine is going to be negative. So I plug in the cosine and get 2/5 squared plus sine squared theta equals 1. That makes 4 over 25 plus sine squared theta. I'm going to go ahead and change 1 to 25 over 25 because I'm going to subtract 4 25ths now and get the sine squared theta is equal to 21 over 25. Now is what's important to know, that the sine of theta is less than 0, because when I take the square root, there's a positive and a negative square root to make this true. But I'm only going to consider the negative because I know, because of where the circle lives on, where the angle lives on the circle, that the sine has to be negative in this case. So the sine theta is the square root of 21, negative square root of 21 over 5. So now I've found negative square root of 21 over 5. This allows me, I've already got the cosine theta. I know to get the secant theta, I just flip the cosine, so that's 5 over 2. To get the cosecant theta, I flip the sine, so that's going to be negative 5 over the square root of 21. We're not going to leave it like that because we have a radical in the denominator. So we're going to multiply the numerator and denominator by square root of 21 and get negative 5 square roots of 21 over 21. To get the tangent of theta, I'm going to take the sine and divide it by the cosine. So I have sine negative square root of 21 over 5, and the cosine was 2/5. When I invert the bottom and multiply, I get negative square root of 21 over 5 times 5 over 2. The 5's cancel, leaving negative square root of 21 over 2. So the tangent of theta is equal to negative square root of 21 over 2. Cotangent, flip the tangent, 2 over the square root of 21. I'm not going to leave it like that. I'm going to multiply the square root of 21 over square root of 21 and get negative 2 square roots of 21 over 21. And these are the types of problems that you'll see. We'll do a couple more. If I gave you an angle with a terminal side, doesn't matter how many times it goes around, it's where the terminal side is. This is my angle theta. It's in the third quadrant. Over here, we know the cosine is less than 0. The sine is less than 0. The secant then will be 1 over the cosine, so it will be less than 0 also. 1 divided by a negative number is a negative number. The cosecant is also going to be negative. The tangent is going to be a negative divided by a negative, or a positive. And the cotangent is going to be positive as well. And let's say this time I told you that the cotangent of theta is equal to 7. So now I can use this to immediately identify the tangent. If the cotangent, and I asked you to find sine theta, cosine theta, tangent theta, secant theta, and cosecant theta. I can immediately identify the tangent by flipping. This is 7 over 1, so the tangent I know is 1 over 7. I can use that third Pythagorean identity and say cotangent squared theta plus 1 equals cosecant squared theta cosecant squared theta. I plug in 7 for the cotangent, get 7 squared plus 1 equals cosecant squared. So 49 plus 1 is going to be 50 equals cosecant squared theta. Now I go back up here and look and say my cosecant is going to be negative. So when I take the square root, I want the negative square root. So the negative square root of 50 is equal to cosecant theta. Now if you see this on a multiple choice test, on a quiz, this will be, this is the square root of 25 times 2, and the square root of 25 is 5, so this becomes negative 5 square roots of 2. That's equal to cosecant theta. Now normally I just flip the cosecant to get the sign. I'm going to go back to here because this is also equal to cosecant, and say the sign is 1 over the negative 1 over the square root of 50, because this is a whole lot easier to work with than this one. Well, I guess not really, but anyway, for me it is. Multiply this by the square root of 50 over 50, and see this is the negative square root of 50 over 50 for the sign. Now I can use the sign, and again I'm going to use the easiest one to get this, alright? So now I'm going to use the first Pythagorean identity and say cosine squared theta plus sine squared theta equals 1. I'm going to plug in the sine. This is equal to the sine, and it's going to be a lot easier to work with now in this form. So I'm going to say cosine squared theta plus negative 1 over the square root of 50 squared equals 1. Well, the square root of 1 over 50 is just 1 over 50, or 1 over the square root of 50 squared is just 1 over 50. The negative squared is going to become positive, so this becomes cosine squared theta plus 1 over 50 equals, I'm going to change this to 50 over 50, so that when I do the subtraction, I get cotangent squared theta, sorry, cosine squared theta is 49 over 50. I recall the cosine is going to be negative. So when I take the square root, the cosine theta equals negative 7 over the square root of 50. When I multiply numerator and denominator, the square root of 50, oh, we said we're not going to leave the square root of 50. That's negative 5 square roots of 2 over 50. So that will reduce to 5 over 50 becomes 1 over 10, square root of negative square root of 2 over 10. And here we're going to do the same thing. We're going to say this is going to be times the square root of 50 over the square root of 50. It's going to give me negative 7 square roots of 50 over 50. Square root of 50 is 5 times square root of 2, so it's going to be negative 7 times 5, or negative 35 square roots of 2 over 50. And negative 35 over 50 is going to reduce to negative 7 square roots of 2 over 10. That's the cosine. To get the secant, I'm going to go back to here and flip this and just get the square root of 50 over negative 7, or negative 7 over square root of 50, negative square root of 50 over 7. And simplify that, negative 5 square roots of 2 over 7. This was 5. That's right. And that's the way we're going to do these problems. Now, one more. I won't always give you a drive. Most of the time I'm going to tell you where on the circle thing lives. The actual problems will say if 0 is less than theta is less than or equal to pi. And secant theta is equal to negative 2. Find sine theta, cosine theta, tangent theta, secant theta. Oh, we did secant theta, alright. Cosecant theta, we're given cosecant theta, and cotangent theta. Now you're expected to look on here and know that if secant's negative, 1 over the secant, or cosecant's negative, we're between 0 and pi, so here's 0 and here's pi on a circle. So if the cosine is negative, it's going to be on this side over here. So when the cosecant is negative, that means the cosine is going to be negative also, because we're going to flip this, so it's going to be negative 1/2. Well, we know on a circle where negative 1/2 is. Well, the cosine is negative 1/2 because that's the point, negative 1/2 square root of 3 over 2. So that tells me that this angle is 2 pi over 3. And I know the sine of 2 pi over 3 is the square root of 3 over 2. I know the tangent, the square root of 3 is sine over cosine. That's going to be the square root of 3 over 2 divided by negative 1/2 equals the square root of 3 over 2 times negative 2 over 1. Negative 2's cancel, this gives me negative square root of 3. Cosecant is going to be the reciprocal of the sine, 2 over the square root of 3. When I rationalize that denominator, I get 2 square roots of 3 over 3. And the cosine is also positive. We know that. Cotangent theta is going to be reciprocal of the tangent, so negative 1 over the square root of 3, and we'll rationalize that to get negative square root of 3 over 3. They won't always be known angles on the unit circle. So if we have let's say pi over 2 less than or equal to theta less than or equal to 3 pi over 2, and let's say cotangent theta is equal to negative 5. Find sine theta, cosine theta, secant theta, tangent theta, and cosecant theta. If you know the cotangent between pi over 2 and 3 pi over 2, here's pi over 2, here's 3 pi over 2. If you know the cotangent is negative 5, that means the sine and cosine have to have opposite SIGN signs. In the second quadrant, the cosine is negative, sine is positive, so the cotangent will be negative. So we're looking at an angle over here where we know the cotangent is negative. This means the tangent is negative 1 over 5. So we can use this, the third Pythagorean identity, to say cotangent squared theta plus 1 equals cosecant squared theta. This will help us find the sine. So we got negative 5 squared plus 1 equals cosecant squared theta. So 26 is cosecant squared theta. Because the sine is going to be positive here, the cosecant is also going to be positive. So when I take the square root, I get square root of 26 equals cosecant theta. I'm going to go ahead and put that in here. That means the sine is equal to 1 over the square root of 26. We'll rationalize that by multiplying the square root of 26 over square root of 26 to get the square root of 26 over 26. And then we'll use the first Pythagorean identity again. That's like cosine squared theta plus sine squared theta. Let's go back to 1 over 26. Square root of 26. Those are going to be a lot easier numbers to work with. Equals 1. So this is cosine squared theta equals 1 over 20 plus 1 over 26 equals 1. Go ahead and write that as 26 over 26. Do the subtraction, get cosine squared theta equals 25 over 26. So cosine theta, we know from our circle, is negative. So we're going to do negative 5 over the square root of 26. Rationalize that. And that's going to give us negative 5 times the square root of 26 over 26. And the secant we can flip to cosine, but this was also the cosine, so we can just flip it and get negative square root of 26 over 5. And that's how we're going to do this.